This video is all about kinematics and calculus and their problem-solving parts. Now, if we're going to define speed, speed is the distance per unit of time. Velocity is the displacement per unit of time. Now, take note. Velocity here is represented as v is equal to the derivative of displacement x all over the derivative of time t. Now, if we're going to consider acceleration, acceleration is velocity per unit of time. A is equal to the derivative or differential of v per the derivative of time t. This is also equal to the second derivative of x or displacements all over the derivative of time squared. Now take note, to integrate acceleration with respect to derivative of time, this is equal to velocity v. If we're going to integrate now our velocity with respect to the derivative of time, this is equal to the displacement. Okay. Now, average speed is equal to the total distance covered or traveled, or the summation of distance all over summation of time. Now, let's proceed with the first sample problem. The velocity v with a unit of meters per second, or meters times second raised to -1 of a particle moving from origin O in a straight line is given by v is equal to 6t squared minus 5t plus 3, where t is the time in seconds after leaving the point of origin O. Now we're going to calculate first. For letter A is the initial acceleration of the particle, and for letter B, the distance from point O or origin when time is equal to 4. Now, if we're going to proceed with this solution, the initial acceleration is the acceleration when t is equal to 0, and we are given with the equation as the velocity in terms of time, 6t squared minus 5t plus 3. Now, let the acceleration at time t be a. Now, we're going to get the derivative of v with respect to time t. Okay? Now, if we do that, this becomes acceleration. So a now is equal to dv all over dt. The derivative of 6t squared minus 5t plus 3 is 6 multiplied with 2t minus 5. Or further simplifying the following terms, this gives us 12t minus 5. The initial acceleration is at time is equal to 0. Now we're going to set time here equal to 0. So 12 multiplied with 0 minus 7. This gives us an answer of -5 meters per second squared for its acceleration at time is equal to 0. Now for letter B, let the distance from point O or origin at time t be s. Okay. Now the distance is represented as s. Now s distance is equal to the integral of velocity dt. So if we're going to integrate the given equation, 60 squared minus 5t plus 3 dt. So we're going to apply the power formula for integral, or the law of powers for integrating functions. This becomes s now is equal to 6t cubed all over 3 minus 5t squared all over 2 plus 3t plus c, where c now is the constant. If we're going to further simplify this one, this becomes s is equal to 2t cubed minus 5 halves t squared plus 3t plus c. Now, For this problem, we're going to set s, or the distance, at 0 and t initially at 0. This is to determine the amount of constant c. Now, if s now is equal to 0, so 0 is equal to 2 multiplied with our time at 0 cube minus 5 halves times our time at 0 squared plus 3 times time at 0 and then plus c. This gives us a value for the constant equal to 0 as well. Okay, because everything is multiplied into 0. Now, if we further simplify this and substitute now the value for time is equal to 0, s now is equal to 2 multiplied with 4 quantity cube, this is our time now, minus 5 halves of our time at equal to 0, or 4, I mean, squared, plus 3 times 4. This gives us 100 for the distance. So the distance from origin when time is equal to 4 is 100 meters. So that ends my presentation for the first problem for kinematics and calculus. Our next video is a second problem regarding kinematics and calculus.